y double dashed minus 12y equals 0, and we've got these initial conditions here. So let's write down the auxiliary equation then. So here we've got lambda squared minus 12 equals 0. There's no y dash term, so there's no lambda term here. So we can straight away do lambda squared equals 12, then move the 12 across, square root both sides. Lambda equals the square root of 12 with a plus and a minus, isn't it? So that's equal to, then there's a 4 times 3 here, so take the 4 out, square root of 4 is 2. So we've got 2 root 3 plus minus. There we go. Compare that as we do with alpha plus minus I beta, and we see that we can read off that alpha must be 0 then, and beta is equal to 2 root 3. There we go, that's what we need. It's the complex case, so it's case 3. So that gives, let's have a look then. Here's the complex case, but the alpha is 0, so that's e to the 0, which is 1. So we simply got a sine beta x plus b cos beta x. So y equals then a sine beta, which is 2 root 3, plus b cos 2 root 3x. There we are, that's the general solution then. Now we invoke the initial conditions. Y0 equals minus 1. That gives, input that then, and see what we get. Here's our general solution. Here's our initial condition. So when x equals 0, y equals minus 1. So minus 1 equals then. X is 0, sine 0 is 0, so that's 0. Cos 0, which is what that will be, is 1, so that's just a b. So reading from right to left then, b equals minus 1. And there's the value of b. Now we need to differentiate. So differentiating then. Gives, so y dashed is equal to, sine is a function of a function here, differentiate term by term. But we've got sine as a function of function, so sine of something goes to cos of something. Cos of something, 2 root 3x, multiplied by the something differentiated. Differentiates 2 root 3, doesn't it? Now the second, the cos goes to minus sine, so put a minus there at the front. Then it's sine of the something, multiplied by the something differentiated. So again, 2 root 3 will come out onto it. Now let's impose the initial condition, y dash 0 equals 2. So let's go back down and look at this now. So y dashed 0 equals 2 gives, so when x is 0, y dashed equals 2, so 2 equals, cos of 0 is 1, so this whole thing here is 1. So a times 1 times 2 root 3 is 2 root 3a, isn't it? And then the sine of 0 is 0, so this whole thing will be 0. So then we can read off a. So a is equal to, move the 2 root 3 underneath the 2 on the other side. And so let's just tidy it up. A equals, the 2's cancel, it's 1 over root 3. And then we can, we can multiply by root 3 top and bottom if we wish, root 3 over 3. And there's a. So now we can read off the, there's the general solution, a sine plus b cos. So let's read off the, b is minus 1, a is root 3 over 3. So let's read off the particular solution then. A sine, root 3 over 3 sine. What was it? What was beta? 2 root 3, sorry. 2 root 3. A sine 2 root 3x plus b, which is minus 2. Sorry, I've got to go back up again. I need to check that b is minus 1. So it's minus 1. And then it's cosine 2 root 3x, isn't it? There we go. There's the particular solution.